Let me run you through a classification problem. In a classification, what you do is, better let me open the file itself. See, in this specific case, if you look at it, and there are certain parameters, whatever they may be, and along with it there is a score here. This is the classification. This particular data, in this particular data set, you will be seeing that the data is organized into 3 different classes. The purpose of a machine learning model using classification is to predict the class if I pass you an input data set. So what is this data? It's I picked the weed seeds data set. These are all the parameters. So area, perimeter, compactness, length of kernel, width of kernel, asymmetry coefficient, length of kernel group, and the class. This dataset is tab separated and doesn't have a header. So I made some basic pre-processing here to pull the data into a proper format. Okay, this is the dataset which I'll be using here. Now, okay, load the data. A new workflow. Okay, simply drag and drop. This is the easiest way for you to process a file. Based on the top 50 columns, this is what the system predicted it. Now, if you want to process this data and if you want to extract output of it, what exactly do you need out of this? First is input data. Second is normalization. Third is correct format. So when I say correct format, for example, the classification should go as string, because even though you look at it as a number, system expects it as a string there. After that, what will you do? You partition your data into test data, training data, and validation. So this is your pre-processing for the data. Once this is over, you will be running your model on top of that, and that is how the system works. Now let's try to do the same thing, implement the same thing here. So I already configured the data. So if you look at the file table here, this is the data you're looking at: area, perimeter, compound, whatever. Okay, now see, the class is I. Easiest way for you is to go to extract table specification, output, input, execute. What are you seeing here? Class is a number, type integer. I need it as a string here. So what can I do? Number to string. That's the only column which I need to mark it as a string here. Configure, except class, everything goes. Okay, execute. What is the transformed output? It's a string here. You want to validate it again? No big deal. Put it again. Sorry. Execute. Okay. Because this is a string, there is no lower and upper bounds here. Happy. What is the next step for us? Probably we can give a sort of color coding for this. There is a node for color manager here. What this does is, I can assign a color to a particular value. Here I have a class. For this class, this is the color coding or whatever I want to give. Set 1, set 2, set 3, whatever. So now if I run this and if I look at the output, see, this is the purpose. all three are coded as different colors, so it's an easier visual identification. Now the next step is to partition the data. I need to do it three way, so I need to have two different partitions here. Copy paste. Okay. This one will go here. So how do I configure this? Standard is 70-30. Let it be like that. It's random sampling. Okay, execute. So if you look at it, the first set contains 139 rows. Second one contains 80 rows. The same configuration 70. So now if I execute this, the first set contains 42 rows. Second set contains 18 rows. Okay. Now I need to run my classification model on top of that. I have got multiple options here. I have a decision tree. I have a random forest. I have SVM. I have everything here. So let me go for SVM for a change. It doesn't matter. Just we are trying to understand the system here. You have learner and predictor. So what you do is you have your partition here. This goes as an input to the learner. So this is the data which the system uses to learn. This is my output model. The output model goes as an input to the prediction system, and the second data set goes as an input as test data. So rather than trying to manually compute, you have a scorer node which you can happily use it. Use this. So what do I do here? Configure. See, class column is fine. Execute. Now execute the predictor with the second partition dataset and configure the scorer. What does the scorer has? Scorer has two classes, class and prediction. This is what you are verifying it against. Accuracy statistics. See, it's 90.5% accuracy. That's what we are seeing, which is actually something very good. Now what you need to do is you need to have this model as an input for further processing. In case you want to export it to a different location, and that is your live production system or something. So what you do here is go for PMML writer. You go for PML writer. Okay, just configure. It'll ask you where to save it. Standard thing. Save as stuff. Okay. Now this model is available for us. Execute. Now how do you use this? Next step for you is to go over a PML reader. What does this reader do? Takes the same file as input, process this, and then pass this as an input to PML predictor. Now the second one is your data set which you want to verify against. Okay, I get my data set and then execute. So what do I get here? I can do it just like that. See, this is there is a wrong match here. So in effect it is working just like the training set. So just same properties, right? Accuracy statistics 94.1%. So we are happy. So high level, this is what you will be doing when you are trying to process a KNIME workflow. So here I used SVM learner. It can be random forest, it can be XGBoost, it can be a decision tree, it can be anything there.